Okay, hello class. This is a problem that was assigned for homework. It's an optimization problem, and I'm just going to go over it again. So you're given a wire. The wire is 24 inches, and you are asked to cut the wire such that cut the wire and make you're supposed to make a square and a circle out of that wire. And you're supposed to do that such that you get the maximum area of the square that you make and the circle that you make. So basically, you're given materials for the perimeter of these shapes, and you have to figure out where to cut the wire so that you get the biggest area. So let's just start off with some things that we need. So I know that if I have a square, the perimeter is I'm adding up all the sides. And for a circle, the perimeter is 2 pi r. Okay. So if I am cutting the wire at x, we don't know what x is, and let's say I use the first piece of wire I cut to make the square. Well, if the first piece of wire I'm bending, so it's x length, and I'm bending it to make the square, then that length is going to be divided by 4. Whoops, I don't know if you guys can see that. Let me do this again. Each side is going to be x over 4 because x was used to actually make the square, and 1/4 of that is the length of each side. So the area of the square is going to be base times height, which is x squared times 16. So the area of the square is x squared over 16. Now, the rest of the wire, which is 24 minus x, that was bent to make the circle. So that 24 minus x equals the circumference. So 24 minus x equals 2 pi r. And I'm going to solve for r here because remember everything has to be in terms of one variable. So 24 minus x over 2 pi, that's the length of the radius. And what's in the area of a circle? Well, the area of a circle is pi r squared, and we've already solved for r. So in this case, it's going to be pi times this right here squared, okay? So it's going to be pi times, whoops, 24 minus x over 2 pi, the whole thing squared, okay? And basically what I'm going to do is I'm going to take the area of the square, which is right here, the x squared plus 16, and the area of the circle, and I'm adding them together because I'm using the wire for both. I'm going to find the derivative because that's what I need to do to optimize. I'm going to set that derivative to 0, and it's going to give me the x value that will give me the maximum area for the square and the circle, okay? So why don't I find the derivative of them separately, then I'll put them together. That might be a little easier. So the derivative of x squared over 16, well, that's just 2x, so area prime for the square. That's just 2x over 16, which is just x over 8. So let's leave u aside, and we'll come back to you. And for this, the first thing I'm going to do, I think, is I'm going to multiply that out. And so I'm going to get, so I haven't found the area yet. So this is area of the circle, and it's pi times, let's see, 24 times 24 is 576. So 24 minus x times 24 minus x over 2 pi times 2 pi. So this is what I'm calculating. Let's see, minus 48x plus x squared, and the whole thing is over 4 pi squared. And that's the area of the circle. And let's see here. I'm going to go ahead and distribute this pi. So I have area of the circle. Actually, I can just cancel it out, right? We can just cancel this out. So now I'm just left with, that cancels out, and I'm just left with 4 pi over here. Oops. So over 4 pi. Okay. And we can use the quotient rule, or I can just rewrite this as 576 over 4 pi. Since my denominator is one term, I can do this, minus 48x over 4 pi plus x squared over 4 pi. And let's see, can I reduce anything or make these numbers smaller? I can reduce here, but when I find the derivative, whoops, this is a constant, so this is going to go away, so I'm not really going to worry about that. But 48x over 4 pi, I can reduce that, so before I find the derivative, I'm going to go ahead and do that one. So area equals, again, 576 over 4 pi minus x, not, oops, 12x over pi plus x squared over 4 pi. And now I'm ready to find the derivative of the area of the circle. So 576 over 4 pi, well, that derivative is just 0. So negative 12x over pi, that derivative is just negative 12x. Oops, I'm sorry, just negative 12 over pi. And x squared over 4 pi, that derivative is 2x over 4 pi. But again, I can reduce that to just x over 2 pi. So I'm going to go ahead and just do that now. X over 2 pi. Okay. All right. So again, let's go back. Here was the derivative of the area of the square, x over 8. Here is the area of the derivative, here's the area of the circle after I found the derivative, so I'm going to put them together and set them equal to 0. So let's see here, I have x over 8 minus 12 over pi plus x over 2 pi, and when is that going to equal 0? And I'm going to find a common denominator here. And the common denominator here is going to be 8 pi. So let's see here. And you'll see why I'm doing that. So let's see. My new term will be x times pi minus 12 times 8, which is minus 96, plus 4x, and all of that equals 0. And now I want to solve for 0. I don't really care what's in the denominator here, right? So when will x pi minus 96 plus 4x equals 0? Let's get everything with the x on one side and everything that's not an x on the other. So x pi or pi x, doesn't matter, plus 4x. When will that equal 96? I can factor out an x here. Pi plus 4. And x equals 96 over pi plus 4. So that is the length of x. And here, let me get my calculator out. So my wire is 24 inches long. And let's see, 96 divided by pi plus 4. And that equals 13.44 inches. So just to recap, back to the beginning of our problem, I'm going to cut this wire at 13.44 inches, and I'm going to use that to make my square, and then the remainder of the wire, which is 24 minus that, or 10.55 or 10.56, to make the circle. And that will give me, so cutting the wire at 13.44 will give me the maximum area for both.